Good morning. Welcome to lecture number 11. So today we're going to talk about NetCDF data in Earth physical sciences. Okay, I wrote Earth physical sciences here because I does not want to limit the data to just oceanography or even atmospheric. Okay, so it's Earth physical sciences. Okay, the data format that we use in this field of study. So we call it Earth physical sciences, including oceanography and meteorology. Yeah. So what is actually NetCDF? Yeah, so this is just a very trivial thing, but good to know. All right, not really important, but good to know, especially let's say you want to download this NetCDF library, meaning you want to enable your computer to be able to read NetCDF. You need to install software from the developer. Okay, so NetCDF is developed by this Unidata, all right, University Corporation of for Atmospheric Research, or we call it UCAR. All right, this is in US. If I remember correctly, they have a very like a red brick building or something, yeah, which they are very proud of. And you can Google and have a look, UCAR, NCAR, UCAR. So sometimes they accept people who want to work there. So in the future, let's say if you have chance, if the opportunity, you can try to apply, let's say, to work there. Yeah? Let's say as a visiting researcher or something. Yeah? So UCAR. So those people, they develop this NetCDF. Okay, NetCDF. So it is usually self-describing. If you still remember, when we say binary data, which self-describing, it means the data have metadata in it. Okay, so you have a metadata embedded in it. So metadata is a small piece of data that explains your whole data. Okay, so for example, I give you a value, a group of value, a group of numbers. So if I don't tell you anything, if I don't provide you with the metadata, so you don't know what these numbers are, right? So it might be anything. It might be sea surface temperature. It might be wind. It might be pressure. You don't know. All right. So usually NetCDF come with this self-describing data. Okay. In fact, most of the NetCDF data, I think all the NetCDF data I provided to you is self-describing data. But there are some format of NetCDF that is not self-describing. Yeah, there are some cases, yeah, but not often you come across data like this. So usually they are self-describing. So you should not have any issue working with them and understanding what the data is about. And it's machine independent. So when we say machine independent, it means that, let's say if I created the NetCDF data on my computer, yeah, and I pass it to you, yeah, you are using on a Mac computer, a Linux computer, or even any computer, yeah, you can read it like what I did. I mean, you can read it as it is, as what I have created. Okay, so the same. Let's say you create the NetCDF data on your computer, you pass it to me. So when I open it, it will be just the same. Okay, so that's what it means machine independent. Yeah. So and just like every binary data, right? So you need a specialized software to work with NetCDF. Okay, so among these common software, the first one, Climate Data Operators, CDO, which is actually a very, very useful data that you have been using it last semester, right? So it's just like a calculator for NetCDF. This is developed by Max Planck Institute. So the second one is called GRADS, Grid Analysis Display System. So this software usually we use to plot NetCDF data. So this is the software that I've been using. If let's say I plotted some maps, I show you, right, as an example. So I use this software, right? That's why sometimes I can pick out somebody if they steal my figure, because I use this GRADS software. So the reason I didn't introduce this GRADS to you, even though I have been using it, is because this software need to do a little bit coding. Yeah. So I think you might not like it that much. So I didn't teach you GRADS. But should you want to do a project under me, yes, you have to know GRADS because it is very useful. Yeah, you can just like if you know a bit coding, you can straight away plot many figures from this NetVF data. You can plot even like 1,000 figures in one go. Okay. So the third one is MATLAB. Yeah, so MATLAB is a very, I would say, a very common programming, I would say, software. A very common software in use everywhere, lah, especially for oceanography. Yeah, in fact, you can get a MATLAB license for free because UMT subscribe to this MATLAB license. So if you are interested in getting MATLAB, you just head over to the MATLAB website. Yeah, mathworks.com. Okay, you register an account using your UMT email, the ocean.umt.edu email. Yeah, so you register it with you register an account. So they will provide you license. Okay, so after you install the installer, you download the installer, you install the MATLAB. So during the activation step, it will ask you to log in, right? So you just log in with your UMT email. So by doing that, you can get original license, I would say license MATLAB, which lasts for like 1 year lah. So this is MATLAB lah. If you like to use MATLAB, I have been using MATLAB. And the fourth tools that commonly people use is R. Yeah, I think you heard of it. If you are not very expert in it, you heard of it, R. Yeah, so or you call it R Studio. Yeah, but actually the real software that actually works NetCDF is R, not R Studio. Yeah, so R is developed by this CRAN, C-R-A-N, and R Studio is developed by third party. Okay, so R is just the original R. If you have opened it before, it's just a command prompt. So it might not be friendly to like beginners. Okay, so somebody wrote a program, like we call it a wrapper, yeah, to provide R with the graphical user interface. So that's why you always say R Studio, R Studio. But actually the software is R, not R Studio. All right, R Studio is just the wrapper. And the last one is Panoply. Yeah, Panoply is a graphical user interface based software. You have been using it. I introduced this to you because I think this software, because it has this graphical user interface, so you might not be so scared to work with NetCDF, because I have been teaching a lot of people on NetCDF, grads, CBO. So whenever, maybe CBO, they are still okay, but when they come to grads, they are a bit worried. Okay, because when you open grads, it's just a black color terminal, you need to type command. So people are afraid. Yeah, but actually it's not. It's just very easy. All right, so I come across this Panoply. So Panoply is developed by NASA. Okay, so using Panoply, you can easily display your data lah. So if you should already have experience on this lah. Okay, and CDO and Panoply and maybe R are the tools that you are going to use for a tutorial. Okay, if you want to use MATLAB, it's fine as well. Okay, so these are the three tools that you are going to use later in the tutorial is CDO, obviously, MATLAB or R, and Panoply. Okay, so these are the common tools that we use when we want to work with NetCDF. Okay, all right, so as expected, so NetCDF is a binary data, yeah. So something like this. This is a station observed data that I wrote in NetCDF format. All right. So let's say you don't know what format this is .nc, right? If you have a file for a data format that you don't know what it is, the first step is you can open it with text notepad. Yeah. So sometimes the data may be .abc, because the extension behind it has no meaning. Okay. You can basically name your file with any extension. Okay. But it is important for Windows. Let's say you name your file as .jpg. So when Windows look at that file, it knows that it is a picture. All right. But you can just name it anything. Yeah. Let's say my profile picture .abc. You can name it like that. Okay. Of course, Windows cannot open it. But if you tell Windows what software to use to open the data, Windows can open it. All right. So remember, file extension is not that important, but it is useful to tell us what type of data or what type of file it is. All right. So let's say you are beginners. I provide you with SDF data and you didn't follow the class. So what you can do is you open this NetCDF file with a notepad. Okay. Here I use a notepad++. Yeah, a free software. I like it. I like to use it a lot because it's much more convenient than the normal notepad. Yeah. So you can straight away open your data file. Okay. So if you get rubbish like this, garbage like this, okay, something that you cannot read, you know that it is binary data. Okay. Of course, some you can see, you still can see like ambient temperature or something, right? So those information are written in text, but most of the data is binary. That's why when you open with Notepad, you only get garbage like this. Okay, so you immediately you know, okay, this file is binary. Okay, this file is binary. But if you let's say open it and it display nicely, all the data display nicely, so that data is ASCII format. Okay, remember, even though the data can name dot something, okay, as long as you open it, it show you text, it is ASCII. If it show you rubbish, it is binary. All right, so like this, you have SDF, you open with Notepad, and you open it with Excel, you get rubbish like this. So it is a binary data. Okay, so it cannot read like how you read your ASCII data. Okay, so I hope you are clear later. Don't like, I mean, don't panic. Why when you open the file, you get garbage like this? Because the data is in binary format. Okay, so how to get data from a binary format or a data stored in binary format, for example, in SCDF. Yeah, so I like to analogy I like to analog this NetCDF data to like a seal box with hidden treasure. Or for example, your parcel. You bought something from Shopee, right? So they send you your product. Okay, but they don't, let's say you buy what you usually buy in Shopee. Let's say you buy okay, anything. Let's say you buy a phone from Shopee, I don't know. You buy phone online, I don't know. So let's say you buy a phone online. So do they send you just the phone or they send you with the box? Right? So obviously they send you with the box. And outside of the box, they put some wrapper, right? They wrap it nicely with bubble wrap or everything. Okay, so when you want to get your phone, okay, that you bought online, right? So you have to remove the wrapper. You have to open up the boxes, so only you can get your phone. All right. So NetCDF data is just the same thing. Okay. So the value or the observed value is stored inside this seal box or binary format. So with treasure is the thing that we want. So it's the information we want to extract. So when we want to extract the content, we have to remove the wrapper. You use a scissor, you use a piece of knife to cut open the box. Okay, so you can think it like the scissor is a tool, right? I don't think you use your hand to peel off the seal, right? I mean, if you use your hand to peel off the seal, your hand is the tool, right? So you use a tool, So tool is a software to open the box seal, so the binary data. Okay, so you use a software to read this binary data. Okay, so this is how you can visualize the workflow when you work with binary data. Okay, so this is some analogy you can put in your mind. Okay, so what are some useful tools to work with NetCDF? So what are some useful knife, scissors to cut open the box? Right. So of course, Panoply, you are very familiar with this one. Okay, you can download this or NCView for people who use Linux. I don't know Linux, but usually we just go for Panoply. So not really. I don't really want to go into detail things like this because we have covered this Panoply, but I include also how to use this Panoply. By the way, you can now download the new version of Panoply. I contacted the developer, so he told me how to install a new Panoply. So of course, Java 8, if you still use version, I provided in last semester. But if you follow the link in Oceania I posted, so install this Java 10, yeah, or 11. Okay, the link is also in Oceania. I didn't upload the software, so because I want you to know how to download the software, the software needed. So you can download Java 10, you install it, and you download Panoply. So again, Panoply you don't have to install. Okay, you only install Java 10. Okay, so these are some steps. You just go through by yourself, yeah? So just a refreshment in case you don't remember. So of course, first, when you launch the Panoply, okay, it show you like this. Then you select the data that you want to work with. Yeah, like this one. And you open it. Then it show you the metadata of that CDF. Yeah. So you know how to read. Do you know how to read this? I think you know how to read this. You should know how to read this metadata. So like this one, you have a UA 850 850. So it's an eastward wind. So you have time. So these are information that show you the metadata that describe this CDF data. Okay. So of course, then you select the variable you want to plot. You create a figure. You get things like this. Then you adjust it so you can get figure like this. Yeah. So I hope you still remember. But I think the tutorial I don't really ask you to plot map like this. I don't think you need Panoply. Yeah. But don't know. Up to you to decide. Okay. So after you import the data, so you can of course click at the array, so you can get the data in a ASCII format. Okay, so you can export your data in .csv in case unfortunately you still dare not work with NetCDF. Okay, but you need to complete your tutorial. You have no choice, so you can use method export to CSV. Select the variable you want, right click, export to CSV. Okay, don't forget, yeah. All right, so more advanced tools, climate data operators, CDO. Yeah, of course there are other tools listed here. In fact, even QGIS. Yeah, if you realize, I actually also included QGIS installation link. I mean, link to download this QGIS in Oceania as well, in case you prefer to use GIS to plot your figure. Okay, I think you also learn about QGIS in I think Mr. Ilham's class. So let's look at what CDO is. Okay. All right. So climate data operators is developed by this Max Planck Institute for Meteorology. It's German, Germany, German. So it's an open source and free software. Meaning you don't have to. When we say open source, right? It's just like when you write the coding for this software is actually open for everyone to check. Okay, so everyone can just read. Okay, how they create this software. So it's what it means by open source, and it's free, and we don't have to pay any money when we use the software. Okay, and it included many operators. So operators just like on your calculator, plus, minus, multiply, divide, something like that. Okay, and usually very small. Yeah, you already experienced the file is maybe just a few, I say less than 100 megabyte or something. Yeah, and it have more than 700 operators. It's still growing. So these are some of the function you can use to work with NetCDF using CDO. Example, calculate statistics, calculate arithmetic. So statistic, if you still remember, mean, median, maximum, minimum. Yeah, arithmetic, plus, minus, multiply, divide. Yeah, arithmetic, statistic. And of course, you can do data selection, meaning select the year that what you want, select the month that you want, do a subsampling, or even do a spatial interpolation. Okay, so these are a few common usage we can use with. We can use CDO to do it lah. Okay, so not necessarily you have to limit yourself to CDO. Okay, so remember the software that I introduced here are just a suggestion for you. Okay, use whatever software that you like. Okay, and of course, remember CDO, it does not have GUI and does not have this graphical user interface, but terminal and command prompt. Okay, so I always like to think CDO as like a calculator. Okay, like a calculator for this NetCDF moment. Okay. So the screen of your calculator is like a computer screen. Okay. So the keyboard of your computer is just like the keyboard, the number board. Moment, let me silence my phone. Sorry, I forgot. Okay, so the number pad, sorry, the keyboard is just like the number pad on your calculator. Okay, so you of course you key in your input. Okay, you do the operator, then you press equal to get your output. Okay, so the same thing for NetCDF lah. Sorry, for CDO lah. Okay, so using how to use CDO to do things like this. So yeah, why so weird? I think I missed out the start of the arrangement. It's okay, just think it like a calculator. So so we want to use CDO to do calculation from NetCDF. So what are the steps that we should use? Let me choose. So you read the information sticker, all right? So information sticker here, you can think it as the metadata of your data. All right, so when you receive a parcel from someone, first you check if the parcel belongs to you. Yeah, or it might send to other people. Right? Is it from the correct seller to the correct, are you the correct receiver? Something like that. So you read the label of NetCDF. Okay, so the same thing, you downloaded the NetCDF data, you read the label. So how you read the label? Sorry, the label is something like this. Yeah, the metadata. Okay, or we call it the header of NetCDF. Okay, so what you tell us what are the data or what are those data that contain this NetCDF? All right. So example like this one, I zoom it in this metadata. Although I assume you to know what it is, but I will still quickly go through. So I have a data file known as this PR ECF RecCM4 historical srf.nc. So I have this file .nc. I got it from somewhere. So I wonder what is in this file, right? What is in this box? So first we read the label. So we extract the metadata. So the metadata told me the longitude have 227, the latitude have 164. This is meaning grid. Okay, 227 grid, 164 grid. Okay, so 227 in the x direction, 164 in the y direction. Okay, then we have 672 times that. Okay, in the data file, 672 times that. All right, so let's look at the variables. Yeah, so the variable, when we look into it, we have PR. What is PR? PR is precipitation flux. So the long name is total precipitation flux. And what is the unit of the data? So it's kilogram per meter square per second. Yeah, so this is the unit for our rainfall. All right. So these are some missing values. This does not really matters. Okay. And it's not other like longitude. So longitude is degree east, latitude is degree north, and the time is since like this. This is the unit. So how many hours have passed since 1950 January 1st, 12 p.m. Yeah. So this help us to know, let's say time step number 1 is already how many hours since this date. So let's say you get 0 hours since 1950 January 1st, 12 p.m. So the first time step of the data will be 1st of January 1950, 12 p.m. Something like that. Okay, so this is how you read the metadata. Okay, this is how you read the metadata. So how to get the metadata? You might ask. How do you get the label of the NetCDF or the NetCDF box, right? So there are a few ways. Yeah, of course, the most direct way is we get the NetCDF library from this Unidata EUCAR website. Okay, so library here is a computer term. Basically, it means a small software with instruction telling the computer how to read NetCDF. It's a very small piece of software to tell the computer how to read NetCDF. Just like now, I'm telling you how to read NetCDF. So I put this library in your mind, in your brain. Okay, I install this library in your brain. After that, you already know what is NetCDF. Okay, so the same thing. So for the computer to know how to read NetCDF, so we need to provide it with a small software, which you can call it library. Okay, NetCDF library. Okay, and when you do that, you type in the command prompt and the terminal and Msda -h in a file. Okay, so another way is you use panoply. Okay, the simplest way, and I think you like the way you will use it the most. Okay, so you launch your panoply. Sorry, you not launch your panoply. So you input the data, and then it will show you the metadata. Okay, like this one. So you can read from there. Okay, of course you can also use CDO lah. Okay, but I don't really like CDO. Only sometimes I use. Okay, so mainly what I use this Msda -h, -h, because I have installed this NetCDF library on my computer. Okay, so for you who have not, and if you don't like a lot of typing command, you use panoply. Okay, just load the data and it will show you. Okay, just that simple, yeah. And of course, okay, so I explained here in detail. Let's say you get the metadata, how you should read. So I just skip this one because I already mentioned it just now, yeah. And how to use CDO. So of course, to use CDO, there is only one rule of thumb. You read the user guide, okay, which you can download from here. You read the user guide, okay, because there are so many operators, even I myself cannot remember all. There are more than 700, I think close to 1,000 operators. Yeah, there's not easy way to remember everything. So you will have to always refer back to the user manual. Okay, this .pdf thing. All right. So how do you use CDO, the flow? First, you should already know. So, but let's treat it as a refreshment class. Okay. So first, you launch your terminal, obviously. Then you call CDO in the command prompt of terminal. So when you call CDO, you type CDO, right? So it's just like you're pressing power on the calculator. Okay. Then you have to determine what you want to do. Let's say your task is to calculate the temporal mean. So you look in the user manual, you look for temporal mean. Okay, so you decided the operator that you want to use is known as, let's say, TIMMEAN, TIMMEAN. Okay, that is the operator you want. So it's just like you decide which button you want to press, plus, minus, multiply, or divide on your calculator. Okay, then you specify the input file you want in CDO. So in calculator, you key in the number you want. Okay, 2 plus 2, for example. So 2 is the input, plus is the operator. So after you specify, you call CDO, you specify the operator you want, you specify the input file, and then you give it an output file name. Okay, you give an output file name, any name you like. Okay, so when you do this, it's just like you press equal on your calculator. So 2 plus 2 equal. So equal is your output file name on calculator, just like on calculator on CDO, yeah? So it's just that simple. Okay, so the full syntax of CDO, of course, you have CDO operator. If it has any option, example, you need to select year or something. So your input file and your output file. It's that simple. Okay, and I hope you can remember things like this lah. Okay, because this is very, very, very basic. And of course, this is a reminder, read the user guide. So why I keep saying read the user guide? So let's look at the user guide. The most important part will be the index. Okay, so the index. So let's say you want to calculate something. Okay? You want to calculate, let's say, arithmetic. So you look where in the user guide show arithmetic. So you say, okay, 2.7 arithmetic. So what type of arithmetic you want to calculate? You want to calculate, let's say, multi-year monthly arithmetic. So you look at multi-year monthly arithmetic or multi-year seasonal arithmetic. You saw it, right? Go to page 81. So you click this button, you go to page 81. So it will tell you if you want to do this certain calculation, what you should do. Okay, so I think I will do a quick demo for you. Let me find my user manual here. Okay, this is the use. You can see this, right? So this is the user guide. You can see it, right? Can you?
Yes, doctor.
Okay, good. Because I worry the sharing is not does not appear. Okay, so you open this user guide, right? Let's say we want to calculate arithmetic. What is arithmetic? So 2.7. Okay, so we want to calculate multi-year monthly arithmetic. Instead, monthly sum, monthly something, monthly. Okay, so you just click this one. Page 80, right? So you can type here 80, but you just click 80. So it straight away jump to this page. I mean, it becomes 81. But yeah, so you see multi-year, seasonal, seasonal, sorry, yeah, I picked the wrong one. So multi-year, monthly, arithmetic. Okay, so you can do calculation like this. So these are the operators. So you just type CDO, you replace this one with this one. Any one that you use. Okay, you provide your input file 1, input file 2, and this is your output. So let's say 1 plus 1 equal. Easy, right? Let's say go to statistics. Okay, we don't do a lot of arithmetic nowadays. We do statistics. Okay, of course, let's say you want to convert a unit, you have to use arithmetic. Let's say you convert Kelvin to degrees Celsius, you have to minus 273.15, right? So that one obviously is arithmetic. So let's say we want to work with statistics, yeah? So we want to calculate the temporal mean. Temporal mean. So temporal mean is statistic. Okay, so temporal all time steps. So you can see statistical value over all time steps. I mean, obviously, I straight away already know because I check the statistical value. Yeah, and then I go this time step, statistical value over all time steps. So you just click it. So let's say you want to calculate the time mean across time. So you just look here. This is the one. Okay, so the operator to use is called TIM-MEAN, T-mean. So you just substitute this one as with T-mean, right? So T-mean, input file, output file. So if you don't remember, you can see from here. Okay, so you call the CDO, you turn on the power of your computer. So T-mean is the operator you want to use. So this is your input and this is your output. It's just that simple. Okay, so O file or output file, it will store the temporal mean of I file. Okay, so it's just that simple. Let's say if you don't like to use SCDF, you want to use ASCII as well. So you can output it. So let's see output. I don't remember what is the term for. You can just find output. Okay, I mean you control F. Okay, you can use control F if those you don't know. Yeah, so it's under import export. So output. So you just click here. So output I files. Okay, so you can print ASCII output. Right? Or output F if you like your number to have, let's say, a fixed decimal point, let's say 2 decimal point. Yeah, so you can see like this. Okay, CDO output F. This have 4 decimal, 8, something like this. Okay. Or another you can use like output tab. So you have a lot of function. I don't know how many function, but this is a old user guide 2016. I bet now it has more. Yeah, no, it should have more operators compared to 2016 when I downloaded these operators. When I download this software. Okay, so this is how you use the user guide because obviously we cannot do everything. Okay, so this is how you use the guide. Okay, so just a quick demonstration. I would say this is like a refreshment for you and a case study to help you work with the NetSDF data. Okay, so first, of course, you want to check information. So there are various operator you can use. Okay, you can check via this user guide, this one. Okay, CDO, obviously turn on the CDO, the operator you want to use, and the input file. Okay, so why you does not have O file? Right, because this does not show you information. So how do you know when to put O file and I file, O file? Okay, obviously, let's say you don't know. Okay, so you can just check here. Let's say we find S info. Okay, so click here. So you see, oh, you only have operator I file. It does not have O file. Okay, so it means what it means that if you punch in this command cdo S info, it will straight away show you things like this. Okay, you see the example, just like this, just like this. Okay, you use CDO just like this. Right. So of course I added some information here. If you draw one arrow, you are writing the output of this to a text file. Okay. So if you double arrow in append override. So when we I'm not sure you know what does it mean override in computer. Okay. So in computers, let's say you have a file with the same file name, you copy and paste it at the same location. If you ask you, do you want to overwrite the file? So if you click yes, so if you click yes, the old file will be replaced by the new file. So this is what we call overwrite. Okay, so if you output something to a file name, okay, let's say old file.txt, and let's say you type the second command, you write only one arrow like this red arrow once, into the same file name, it will overwrite the first information. Okay, so if you want to store the information side by side, I mean top and bottom, you use double arrow. We call it append. So append, it means put below, put below, put below. Okay, so this is how the differences between overwrite and append. Okay, and then of course this one I told you just now, t-mean. Let's say we want to calculate the mean of the data across time or temporal mean. So I mean, this is an example how you can do it, right? So CDO t-mean input file, output file. Okay, this old file you give a name that you like. All right, so you can check the information. Of course, you can plot it, example, multiply or grades after you do the calculation. Because always remember, visualizing after doing calculation is important, especially for you all, I would call it beginners. Yeah, because you are new to the CDO, so you don't know what is actually happening in the calculation. It's this calculator, right? So what you can do is after every step of calculation, you plot the figure out to check your calculation. Okay, so this is how I learned when I was in my when I was doing my master time. Okay, because I was late being introduced to this CDO. During my degree time, I used a lot of MATLAB. So when I was first introduced to this CDO, I'm not that familiar with it. So I don't know what is actually happening. So what I did is do calculation, plot it out, do calculation, plot it out. Then we see what is actually happening in this software. All right, so you do the calculation, you can plot it out with multiply of grades. Obviously for you, you use grades, yeah? And then of course, you select the time period you want. Example, let's say if I told you, okay, when is the El Niño's happening? Right, okay, you tell me El Niño happened, let's say 1997, 2015, 2019. So example, so you want to select, so the instruction is select those rainfall data that falls in this year, right? So obviously you want to select the year. So you want to select the year, you use cell year. Obviously you can check with the user guide, select year, so cell year. Okay, so of course this is how you type, and the file, the date format have to be like this. Year, month, day, then T is a time, double H is hour, minute, second. Okay, so this is the format that it accepts. All right, let's say if you want to select rainfall data on 21st June, 10th of June 2021. So you type 2021 minus 06 minus 10. Okay, let's say at 10 o'clock. So T, so you write T 10 colon 00 colon 00, because 10 o'clock, 10 a.m., 0 minute, 0 second. So this is how you select the date. Okay, I mean how you read this format. So when I write Y, so 2021 mm 0, 6, or even you can write 6. I think it's okay as well. So dash dd 1, 0 or 10. Let's say 0, 3 for third. Or you can just write 3. Then you write a T, capital T, then the hour, minute and second. Okay. And of course, if you want to select the season, DJF, blah, 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 or annual, ANN. Okay. So just, I mean, this is, of course, this information you can get from the user guide, but I extract it out to help you to make your life easy. Okay, so example here, you want to select the data from here to here, this date to this date. So this is the way we write, how we write we call it the options, the option. Okay. And then number 4, let's say we want to select an area. Okay. Of course, if you are aware, our tutorial today, we are trying to calculate Nino 3.4 index for this El Nino. So we have to use the sea surface temperature over a fixed area. So how do we select that area out of our data? Yeah, so please be reminded that the data I give you in Oceania is actually global sea surface temperature. Okay, because the task is for you to calculate this Nino 3.4. So you need to crop out the region that covers Nino 3.4. So how you do that? How you crop that area out? So, of course, the operator to use is cell long box or cell index box. But obviously here we use cell long box. Then you provide the long 1, long 2, let 1, let 2. Long 1, long 2, 1, let 2. Or you can terbalik also can. Let 2, let 1, does not matter. All right. And you use, let's say if you have, if the value past the 0, at the let's say your latitude is on this southern hemisphere, so you put a negative. Okay, so you put a negative. So if let's say the longitude is more than this 180, it should be equal to latitude negative. Okay, because CDO understand. I think I think not necessary. You also can understand this. Yeah, it does not matter. Yeah, you just key in the longitude. Yeah, I just remember it does not matter. Yeah, so because if you are aware, our coordinate system for longitude, there are 2 different types. One is 0 to 360, another is negative 100 to 180. Sorry, negative 180 to 180. So there are 2 different formats of longitude, right? Two different ways to like write this longitude. Okay, so but for CDO, it does not matter. Okay, you can take any format that you specify. Okay, so you just key in the longitude. Longitude 1, longitude 2, latitude 1, latitude 2 of the, we call it the bounding box, boundary or bounding, right, to bound the area. Okay, so this is how you select the data lah. So I think, of course, this is for those who are, you know, still scared of NetCDF. You want to save it into ASCII, or sometimes you want to not necessarily say scared of NetCDF. Let's say they want to convert the data as an input for another software which don't read NetCDF. So this is how you can do. You can use output that. Sorry, this should be output F. Forgot the F here. So output that, output F, the example. You can some of the example you can use when you output into ASCII format. Okay, so of course you see output that. I want the name, that, date, long, let, value. So this is like output. So you just write CDO, output that, comma, name, that, date, long, let, value, I file, and then you write it up to O file. Okay, just that simple. All right. So I think, yeah, no more. Our class actually reached here, but I provided some supplementary information which can be useful for you in the future or now. Okay, so first, obviously, installing NetCDF library. So for now, you don't really need to do that, but I don't know, in the future, you might need to use it. So these are the steps how to set up NetCDF library in computer, Windows, Linux. Yeah. So these are extra information. So in the future, let's say you require to do that, you can refer this supplementary information 1. Okay, if you require to do that. Okay, and you don't know how to do that, how to install that CDF on your computer. So this is the information you can refer. Okay, so I'm not going to go through this one. This is very technical. And of course, installing climate data operators, you should already know. For Windows, you can just straight away download, extract, and use it. Yeah, by putting the CDO together with your data file. Okay, or you can do something like this so that your CDO you don't have to put together with your data file. Okay, so these are suggestion. At least I did it with Windows 8, but I think more or less the same. The step is more or less the same. You go to control panel, system, advanced system, environment variable, you add, edit, or you add. So you just tell the window where you put your CDO. So for my example, I put my CDO in C CDO. Okay, so I put my CDO here. So I just tell the computer, okay, now you can look into this folder to look for CDO. Okay, so this is, if you want to do it, you can do it. If you don't want, you scared, you might damage your computer, you just put the CDO.exe and the pthread.dll together with your data file. Okay, so of course, the problem with CDO for Windows, you cannot read more than 2 GB. Of course, there are some other new version. I don't want to go into detail because this complicates your task. All right, and for Linux, how you install CDO from Linux computer. Yeah, okay, skip this one. And supplementary 3, this maybe you need to use it to refresh your mind how to use command prompt. Okay, so although we talked about this previously, so this is how we navigate using command prompt on Windows. Okay, so you just go through this step. Sorry, although I use this methodology class, I mean I just copy paste. This is how you do navigation. Okay, so first you launch command prompt. You copy the location that you want. Yeah, so and then you just type something like this. Yes, first you launch it. Yeah, I mean, you just read it. Give it a read. Okay, and extra information. This is, let's say you want to write, we call it the operator chaining. Let's say you need to do a few steps of CDO calculation, but you don't want to type so many times. You want to, let's say in one line, type one time, you get the result. This is how you do it. Okay, we call it operator chaining, but I don't recommend you do it now because unless you are very familiar with CDO, okay, so this you can just go through the extra information. And of course, the most important or the most useful function for CDO is you can do programming. Yeah, so you can use you can write program to use CDO to process the data. For example, let's say you have a lot of NetCDF data, you need to go through a few NetCDF data. So obviously you cannot type 100 times the command, right? You have to write something, let's say a program. Okay, so it will run the CDO 1000 times for you. Okay, so these are a few examples, let's say Windows, Linux, or even on MATLAB. Okay, how you can write the loop. Okay, we call it the looping for using CDO to do the calculation. In fact, R you can use it the same way as well. I didn't include here, but R you can do it because R also have this thing called system, yeah? And then you just key in the command. Okay, like how you should write in a loop. Okay, so I think this does not concern you that much for now, not at least not for the tutorial I plan this time. So probably supplementary information 3 is what you want to have a look. Okay, just to refresh your mind on how to use command prompt. Of course, you can also refer the Amali handout that I give you step by step in last semester. If not, you can just refer this one, how to use the command prompt. Okay. All right. So I think that's all for the class, and we'll move to our tutorial task. Okay. So I think this is the most important part. All right. So I was made aware that you don't want to have assignment. So, but I promise you something that, you know, the assignment is something like your PITA research. So I double them together. All right. So for our tutorial 4, of course, we look into climate indices. Of course, you might ask why like Dr. Jenny show you like the various statistical things that done in let's say chemistry, biology, and geology, but I don't want to show you or I don't want to talk about statistical method because our class is data analysis. You should learn this in statistical classes, okay? And of course, there are so many statistical tests we can use, yeah? So I don't want like, okay, I introduce you to this statistical method. So next time you always will just use the same statistical method. You don't care anything else. So I want to avoid that, okay? So instead of showing you the statistical we should use, so I give you a case study, okay? So we want to explore the relationship between annual rainfall in Kuala Terengganu and this El Nino Southern Oscillation. And so, okay, of course, the approach we use is linear correlation. Of course, you might ask, a linear correlation is a statistical test, yeah? But this is just a case study, of course. If you do a full research, you cannot just use linear correlation to say that, okay, the rainfall is related to ENSO. Yeah, so there are many more tests you need to do. So, but linear correlation, please think it as a case study. Okay, I don't want, because I don't want to like fix you to any statistical approach. Linear correlation, it's just an example. Okay, so let's say when you do your PITA, yeah, everything you use linear correlation. I don't want you to do that. All right, because this is just an example. Yeah. Okay. Let me close this first. Okay, let's go through tutorial 4. Of course, complete the task given and submit a group report. Okay, so you can write everything in a Word and you save it in a PDF and submit to Oceania. I don't have Excel file for you to fill. Okay, so but you can answer. The report should be based on the question asked. Okay, the question asked or the task given to you in this tutorial. Yeah. So introduction, just very briefly, you can read through. So when we describe and monitor the state of climate system, so you often use a tool or diagnostic tool we call climate indices. Yeah, climate index. Okay, so might become darker. So we want to see, we want to use climate indexes to help us to understand how related is the annual rainfall, year-to-year rainfall or yearly rainfall in Kuala Terengganu is to this fluctuation of El Nino. Of course, I think you should already know very well El Nino. What is El Nino? Like La Nina, La Nina, El Nino. El Nino is a dry phase over our region, but La Nina is a wet phase of ENSO in our region. Yeah. So El Nino usually it will cause dryness in our region, but La Nina will cause actually not La Nina not necessarily cause more rainfall to our region. Yeah, but El Nino, yes, it will cause dry. Yeah, of course, if you read some articles, La Nina, when La Nina occurs, it does not mean that we will have heavy rainfall. In fact, moderate La Nina is the one that gives us more rainfall, not the strong La Nina. For some, we don't talk about that. So the focus here is we want to know, yeah, if occurrence of ENSO will impact the annual rainfall over Kuala Terengganu. So this is the question we want to ask. Okay, so when we want to ask this question, so the approach that we use is we compare the annual rainfall in this location compared to ENSO Nino 3.4 index. Do you know what is Nino 3.4 index? do you know what is that? Do you have any idea what is Nino 3.4 index? Anyone? Okay, so you know, right? You know what is Nino 3.4 index, right? Okay, so just make my life easy, so I'm not going to talk about that. So you know what is Nino 3.4. All right, so we want to compare things like this, yeah? So what to do in this tutorial? Yeah, first, of course, you state the hypothesis. Obviously, this is the analysis class. So you state the hypothesis. So what is the null hypothesis? What is the alternative hypothesis? So you just write it down. Okay, and then the second one, we prepare observation data because you have some friend ask me where to get station data for rainfall. Unfortunately, if you want to get rainfall data, it's not that easy. Okay, if you want to get from the Met Service, it's not that easy. You have to write letter and everything. Of course, there's another website. Let me show you. I think it's called GSOD rainfall. The data is stored in ASCII, but it is very difficult to use if you don't know how to do programming. Okay, so I think yes, I think it's this one. You have to just I don't, but it's this one GSOD. So like everyone, they have to contribute measurement, ground measurement to a common repository. Yeah, meaning every Met service in the world have to contribute rainfall data to a common repository so that scientists can use it to do calculation. Yeah, but the data can be a bit scary if you don't know how to do programming. Okay, although the data is in ASCII format. So ASCII is easy, you open, you read it, but if you don't know programming, it can be tough. Okay? So but if you really in despair, you need station data. This is, you can check. Let's just go through very quickly. I think we have some time. Wait, let me check. I actually have a program written where to download this data. Let me just go through. Yeah, wait a moment. Sorry, because this is unplanned. I did not want to show you actually, but since I already mentioned it. It has a specific website that you can find. Well, I just search. Wait a moment, yeah. Script. Yeah, so this is the program I wrote. So this is the website. Sorry, this is the website I think. Can you open? Yeah, maybe they already changed the web page, but this is where you can get GSOD website rainfall FTP and OAA. Yeah, I mean it's here obviously. I wonder, is this the problem with Google Chrome? Use another web browser. Yeah, I know why, but in the past it's just easy. You just maybe they already changed the web page so that we cannot easily download it. But let's just go through, let's say, example Malaysia, or maybe Kuala Terengganu. Because we have a weather station in Kuala Terengganu. Or I don't know, it's called airport or something. Jaya. Yeah, okay, we have Petaling Jaya. So you just click it. So you have the data here. So it's in .csv. So you can just download it. Okay, so we have CSV here. And easily you can just double click to open it. Okay, so these are the station data that observed in this EJ. All right, so you can look at here. This is different date. Okay, let's say you want to look for rainfall temperature. This is in Fahrenheit, so you need to convert it to degrees Celsius. I mean, I know because I already read the metadata, yeah. So let's say precipitation here. So this is the rainfall. Okay, if you see 99.9, it means no data. Okay, or this one, it means no data. So when is it? Let's see. It might not be the newest we have. Now, this is 1998. Of course, I think you can do something. You can change the period here, or you do some setting here. So this is ASCII data. All right, you can get data from here. Okay, but let's say if I want to ask you to calculate, let's say the monthly mean is data. So how are you going to do that? Right? So it's not that easy. But if you know how to do coding, yes, you can do it very easily. Okay, so I don't really recommend at your stage to use station data like this. Of course, you can use if you know how to use R, MATLAB to do coding. Yeah, of course, there's some tricks. So of course, you can ask your code to read the month. So find all the May, calculate the mean. Find all the June, calculate the mean. Okay, but not that easy. Okay, not as easy as using CTO. Okay, so let's forget about this station data. But this is where you can get this one. Okay, maybe I post in the chat. Yeah, so please copy it. So if you don't this FTP, don't need. Okay, just search like this. Let me paste in the chat. So those who need the data, you can copy it. You search in your Google, maybe you can do like a bookmark. Okay, so this is where you can get rainfall data, but I cannot guarantee the quality. Of course, there are some units you need to like change. All right, so let's forget about this station data. So if let's say we don't have station data, right? We can use graded data. Let's say we have station data over Kuala Terengganu measuring rainfall. What about rainfall in UMT? We don't have station on that. Okay, so how are we going to get rainfall for UMT? Right. So in this case, we need to use graded data. Okay, graded data is just like satellite observed rainfall. Okay, so satellite observed rainfall. So when satellite move, it takes pictures of the ground. Okay, so by using the picture, it can know where this location have how much rainfall. Okay, so but how do we extract that? All right, so this is so we obtain can be very tough, like I told you here. So we can use rainfall graded data, just like taking pictures here, and we want to prepare year-to-year annual rainfall over a fixed point on Kuala Terengganu. Okay, so after prepare the data, we have to visualize the data. So you should know why, because I will tell you to inspect our data. So to inspect that our data does not have problem. Yeah. So who knows, suddenly you get a rainfall value with negative. So obviously we don't want that. Rainfall cannot be negative. If you don't have rain, it will be zero. If you have negative, it means the rainfall go upward. It's not possible. Okay. So all right. So we prepare rainfall data over using a graded data. Okay. So you have to visualize it, plot it, and then our data. And number 3, we have to prepare our own Nino 3.4 index. Of course, you can tell me why don't we just use the web available? Of course, we are students. You are student. We are academician. So we should try to we should know how to prepare our own index. Okay. So instead of using what available, so you will use the global graded data that I provide to you on this sea surface temperature, create our own Nino 3.4 index. Okay, so after prepare our index, actually it should be annual. So we plot it out. We plot a bar chart because somebody told me they don't know how to differentiate bar chart and histogram. Okay, so here you are going to plot a bar chart, not histogram. Okay, so very easy. When the bar chart is is showing If the bar chart is showing distribution of the data, that is histogram. Okay, if the bar chart is just describing the data, it is a bar chart. Okay, it is a bar chart. Huh? So here we plot our Nino 3.4 index for every year. Let's say yearly. It should be yearly. Prepare our after prepare. It should be. I forgot to put here. Calculate the yearly mean. But don't worry. At the bottom have that. So after that, we prepare our own Nino 3.4 index. We calculate the yearly mean of this Nino 3.4 index. Okay. Then we visualize it in a bar chart. So this bar chart is a graph, a bar graph. Okay. What it did, it tells us, let's say in 1990, how large is the sea surface anomaly over region Nino 3.4? Or how large is the, or how negative, how large the negative, yeah, I mean, it's weird, but how large, yeah, I mean, just, okay, how large is the negative of the Nino 3.4 SST anomaly? Okay, because this it just inform us. Okay, if your bar chart inform you something, okay, it is bar chart. Okay, but if your bar chart describe distribution, then it is histogram. Okay, and when you plot histogram, usually the bar combine together. Okay, combine together, and you can draw a curve. We call it is it frequency polygon? Because in the past I learned this mathematics in Malay. We call it polygon kekerapan. So I think it's a frequency polygon. If the term is wrong, please forgive me. I think it's frequency polygon. So you draw the bar, so you can draw a line. Okay. So in meteorology, we usually draw the line. We do not draw the bar. Okay. So very quickly, I can show you some example of my work. Histogram, but I draw the polygon line instead of the bar. Okay, like this one. So figures. Okay, so this is very small. How to zoom this one? Yeah. Okay, so this is histogram. Okay, so you have a many bar here. So I did not show the bar. I draw the polygon of the line. Okay, so you can see. So most of the time the rainfall is very low, right? So most of the time the rainfall is very low, and you have a bit more high, or I say mid rainfall, because it's already high rainfall. Then very high rainfall also is very few cases of very low probability to happen. This rainfall over 90 mm per day. So this type of graph is histogram. Okay, but of course I plot it curve. I just plot the curve. If you plot the curve, this is called a probability density function. Okay, probability density function. You can draw this in the form of bar. Okay, and when you draw histogram, right? So you have to set something known as class width plus number. Yeah, so meaning, let's say, okay, let's say we try to plot the histogram of the weight of student in this MMS 3012. Okay, so we measure everyone's weight. So we want to know how the weight distribute among you all. Yeah, so do we have a lot of people underweight, a lot of people overweight, or a lot of people normal weight? Okay, but we don't do the classification. We just we just plot it out. Okay, so to draw the histogram, so we have to set a limit. Let's say, okay, 30 to 39.9 kilogram, 40 to 49.9 kilogram, 50 to 59.9 kilogram, until, let's say, 200 to 200.9 kilogram. This 40 to 40.9 kilogram, is it correct? 49, yeah, anything. So that is what we call the class size. Okay, so we do not really classify as lightweight, heavyweight, normal weight, obese. We do not do that, right? So we just want to see how well, what is the distribution of the weight. Okay, and if you adjust the class size, let's say from 40 to 40.9, you convert to, let's say 40 to 59.9. Okay, 60 to 79.9 example. Okay, so now you see the class width become larger, right? So the distribution, the curve will look very different. Okay, so just now you see the line graph that I plotted here. If not mistaken, it has 100 class. Okay, 100 class. So I have my rainfall, let's say 0 to 90 mm per day. So I split them into 100 class. Okay, so each class, it has a certain value. Okay, so this will give me a histogram, right? But let's say you can see this, too small, a moment, yeah. Okay, so this graph is a bar chart. It's a bar graph. Bar graph, right? Why? Because I already classify DJF, MAN, JGA, SON. I already classify. This class size cannot change, or even in fact, it is not class size. It's category. Okay, for DJF. So how much? This is skill score. How good the model perform? So for DJF, how good this green model perform? How good this model perform? So it's already fixed. So this is a bar chart. Okay, so you cannot draw a polygon here, obviously, yeah, because this DGF has no impact on this MAM. Okay, it has no. I mean, of course they are related. Of course, this is the same model, different season, but when you look at the graph, right, it does not have any meaning. Okay, because after this blue line, it does not continue to this blue line, this blue graph. Well, sorry, this blue bar. It does not continue. Okay, so we cannot draw this frequency polygon. Okay, so this is a bar chart. Can you understand? So can you visualize? So when we draw histogram, we decide the class size. Okay, we want to look at the distribution of the data. When we plot histogram, yeah, we want to look at the distribution. And when we want to plot a bar chart actually, we categorize first our data, and we see in that category how much actually fell into that category. Or example here in my graph, so categorize my database on different season, and I compare the performance. So you can see, okay, green, it performed like this, blue performed like this. Okay, so this green line you cannot draw the curve. Okay, of course you draw, but it has no meaning. Okay, it has no meaning. So this is bar chart. Yeah, but instead, if you draw something like this, yeah, you draw many bar. Okay, you can draw curve like this. Okay, so if you can draw curve like this shows the distribution of your data. Okay, so this is basically skewed to the right distribution. Okay, because obviously rainfall, most of the time you don't have rainfall. Okay, that's why the distribution is not normal and it's usually skewed to the right side. So if you can see the distribution from your bar chart, that is histogram. Okay, so we spent a lot of time describing this. So I hope you have a clear idea what is a bar chart. So, and histogram. Just to make sure that you clear, so I included this. So after you calculate your Nino 3.4, you calculate the annual mean of that Nino 3.4 and you plot it out. Okay, so when you plot it out, basically you are classifying the index based on year, so that it will give you a bar chart. Okay, all right, I hope you can understand. So you will see sometimes there are bar going up, sometimes they have bar going down. Okay, and of course, lastly, we conduct a linear correlation test. Okay, so to do that, we compare our, this is step, this is step 2, and this is step 3. Okay, later I will fix this. So in step 2, we prepare our observational data at a point. And step 3, not 2, we prepare this Nino index. Okay, so we want to know what is the relationship between El Nino and this rainfall. So we do a correlation test between the two index. So we compare the annual rainfall to the Nino index. So you use a linear correlation. Okay, so after that, you have to overlay, you have to plot a line graph. I usually prefer line graph, yeah. So you draw a line graph of the rainfall, and on top of it, you overlay this Nino 3.4 index. Okay, because if you still remember, sometimes you get high R value in correlation. It does not mean there is correlation. There is linear correlation. Okay, so plot, when we overlay the Nino index and the rainfall, the two things that we use to calculate correlation, so we can visualize. Okay, we can visualize, is it really having linear correlation? Of course, the best way is for you to plot scattered plot, but I don't want to make things complicated, so you just overlay the rainfall. So let's see, you plot the rainfall and the Nino index together. So we want to see when the Nino index going up, does the rainfall going up or does it going down? Okay, or when the rainfall when the Nino index going down, does the rainfall going up? Yeah, we want to see, does it have this type of pattern? Yeah, so if you calculated, you get, let's say, correlation value 0.8. Yeah, so when you plot the two lines together, the Nino and the rainfall together, you see them go, Nino going up, rainfall also going up. And Nino going down, rainfall also going up. Yes, the two of them have linear correlation, have linear relationship. Okay. I mean, obviously they have linear relationship. If not, I will not ask you to plot it. I will ask you to plot scattered plot. Yeah, but the best way is actually to plot a scatter plot. But just to make your life easy, you just plot a line graph. Okay. And then lastly, this is to help you to plot histogram practice. So using Nino 3.4 index, you identify which year is El Nino year. Okay, based on the definition of El Nino using this Nino 3.4 index. Yeah. Then you select the monthly rainfall of that year. Okay, let's say 1998, 1997 is the El Nino year. So you select the monthly data for that year. Okay, and then of course, let's say 1997, 2000, I don't remember, 2015, 2005. Okay, let's say this 3 years is El Nino. So you select the data for this year, this 3 year from monthly data, you plot the histogram and you see the distribution of the rainfall data. And you do the same for non-El Nino years. So we want to see how El Nino change the rainfall distribution. So this information is given to you from via this histogram. After you construct the histogram, you can see how the data distributed. Okay, of course, why we draw the polygon frequency instead of histogram is because we can overlay. All right, so I teach you how to do this. Let's say you see chips 05. Chip 05 is actually observation data. Okay, the one I provide to you, but yours is 35 kilometers. So red and blue is the one simulated by my model. Okay, so from this graph, right, let's say you plot the histogram. A lot of bar you cannot see. So you plot the line. So you can see, right? So this red model, right, is simulated less the rainfall over this area. Okay, over this range, let's say 5 to 10 mm range. Okay, when it's supposed to have 5 to 10 mm range, so the model is simulated only a bit this light rainfall, example, but it simulated a lot of this high rainfall. You see, is higher than the black line. Okay, so this tells us how the rainfalls are distributed in different model. So using the same idea, but I don't ask you to plot this curve, but you just plot the histogram. You can see, okay, maybe one, the distribution is shifted to the, I mean the maximum is shifted to the right. Okay, maybe one is a bit to the left. Yeah, of course, you will not get a bell shape. Rainfall, you will not get a bell shape. You will get, if you draw bar, you will get pattern like this. Okay, so what I expect to see is there is some shift lah, okay, between El Nino and non-El Nino here. Okay, obviously, to do that, you can use R or you can use Excel. You can use R or Excel to do that. I don't think Panoply cannot do that. Panoply is just to plot map. Okay, so these are the tasks you need to do. So of course, I do not have like question like what Dr. Jenny did. So first part one, you state your hypothesis. So what are the hypotheses? So you just say hypothesis in this, the null hypothesis in this study is the alternative hypothesis in this study is blah. And then, okay, here have some instruction what to do. Of course, first, the point chosen for you is this location. So let's try to find out where this is. This is your task. Try to find out where is this location. Okay, you can draw a map marking the location point. You can use Google Earth to help you. Let me launch my Google Earth. Of course, I think you can use Google Map also because you just key in the long and lat, right? So this one, okay, this you launch a Google Earth. You click this marker, place marker. Okay, let's say you key in the longitude. Let's say 3105 example. So let's see where it went. It go to somewhere in the ocean. So this is the location. Okay, so then you can just name it. Let's say state point example. Okay, of course you can change the pattern. Yeah, very ugly. Everything also very ugly. Anything like this. Okay, so you've done that. So you can just export it to, you can just save it, save an image like this. So we don't need this. So legend, where's legend? Don't need this. Compass is okay. We don't need this. Yeah, so something like this. So you can just save it up. So this show you the location where it is. Okay, so try to find out yourself. Not going to spoil it for you. Okay, so you draw a map. Okay, you draw a map, mark the location. All right, and then of course here I write using any software you are familiar with. Because you can use CDO, but you can use other software as well. So when we want to extract a data point, yeah, there are many ways. One of the common way is what we call nearest neighbor interpolation. Okay, you can use any software you are familiar with. If you want to use CDO, you can check at this notes. So I give you the example command how to extract the data using nearest neighbor approach. Okay, so of course after you extract it, you plot a line graph lah. Because this is a monthly data, it will be very messy. Plot a line graph. I don't want you to plot a bar graph. So hard to read. Okay, and then you calculate the annual or yearly mean. You can use CDO or any software that you like and display your result in a bar chart, a bar graph. Okay, and then you describe what you see. Okay, so I expect you will see sometimes it have a high rainfall, it have a lower rainfall, something like that. Okay, so of course this to help you to use CDO lah. Next, construct Nino 3.4 index. So the definition is SST anomaly with respect to this period across this region. Okay, so El Nino is when the anomaly exceeds 0.4 degrees Celsius. Okay, so these are the definitions. So let's follow this definition and create our own index. Yeah. So first, of course, you crop the data to Nino 3.4 region. This one, cell line box, by the way, if you still remember. Okay, then you calculate temporal mean. Because we respect to this, right? So we calculate the temporal mean for this period. So what is the value? Just show me here. Okay, of course, usually you don't have to write like this, but I want to look at your step by step. I want to make sure you did it right. So you answer lah. So the value of calculated temporal mean for this today is something. Okay, then you calculate this Nino 3.4 index by calculating the differences between SST data and this temporal mean differences. Yeah, so subtract arithmetic. This when you calculate differences is arithmetic, you subtract. Okay, and then of course you plot a line graph to show your result. Okay, just to check that you know what you are doing. Okay, because obviously I only want to see number 4, but just to make sure you do your calculation right. So you plot this line graph to show your result. Okay, and then you calculate the annual yearly mean of this. Okay, and then you display the result in a bar chart. Okay, display it in a bar chart. Yeah, I call it bar chart here because from year to year you don't really draw this polygon. You cannot draw this polygon. We are not talking about distribution here. Okay, so it's a bar chart. And number 4, lastly, we do the correlation test. Okay, so what calculate the correlation of this for at this location and another for this period? For this period, because when you want to calculate the correlation, okay, both time series need to have the same length. Okay, so if let's say the rainfall have 10 years of data, your Nino index should also have 10 years of data. Okay, so you can calculate the correlation of coefficient. So what is the value of correlation coefficient? Okay, a few software you can use, CDO you can use, and of course you use R or MATLAB. Most all of them are easily, it's easy to use. All of them are easy to use, not easy, sorry. So and then of course you overlay them together, you plot the annual rainfall and the Nino index together. Okay, for this period, yeah. And then calculated the p-value. Okay, I hope you know what is p-value. So what is, after you calculate it, what is the p-value? And then you tell me which hypothesis should you accept or reject? Why? Are you confident? I mean, what is the confidence level when you do that? Let's say the H0 should be rejected. So what is the confidence level? At 95% confidence level, example. Okay, so based on the p-value, you tell me how confident are you when you reject your hypothesis. Okay, so this you can refer, I think our week number 4 class, I think. Yeah, week number 4 part 2 on this p-value thing, alpha and p-value thing. So do that. Okay, so here, yeah, I have a step on how to calculate this correlation coefficient. If you use CDO, you can use team call. Why? Check why you use team call. But I don't recommend you use CDO in this case because task number 3 requires you to calculate p-value. Okay, CDO cannot give you p-value, so you have to use R. Okay, or MATLAB. So here I assume you all have R because I think you already installed it in the previous class. So here are the steps you use to calculate the R and the p-value using R, or the correlation coefficient and the p-value using R. Okay, so these are the steps. First, you can convert the data into ASCII format, or if you know how to read NetCDF in ASCII, NetCDF in R, you can straight away skip this step and import your data into R and do the calculation. Okay, if you follow my steps, so these are the steps you need to do. Okay, and then use this core.test function to do the calculation. For example, core.test Nino, rain. So it will give you R and P value. Okay, so this is supposed to be very easy. Yeah, I will try it. You can done this in like say half an hour. Maybe for you, I say 3 hours. you should already done this. Okay, lastly, usually here should be the end of our tutorial, but I think I added this to teach you the differences between histogram and bar chart. Okay. Yeah, why I write like this? Sorry, this is wrong. Maybe when I wrote it, I have to fix this. Objective is actually want to help you to identify the usage of histogram. Yeah? So this is actually to help you to identify the usage of histogram. So of course you use the annual index you calculated. So you list now in a table. So what are the years El Nino occurs? Okay, let's say 1997, 2015, and what else? Okay, then from the money data at this location that you extracted, so you select those that fell on El Nino years. Say 1997, 2005 or something. So you select those years out, construct a histogram. You should know how to construct a histogram, right? In Excel. Okay, so you extract those data, you output it into ASCII format, and then you paste into Excel, and you draw the histogram. Okay, and then you do the same for those that are non-El Nino. Okay, you plot the histogram, and you see, then you compare the histogram, and you describe the differences between them. So how different is histogram for the data from El Nino year and non-El Nino year? Okay, so we want to look at the distribution. So when you plot the histogram, you have to make sure they have the same class limit and the same number of class. Okay, because remember, if the histogram have different classes, different class limit, different number of class, the distribution you plot or the histogram you plot can have very different pattern. Okay? So make sure the class or the bin or bin, the bin have to have the same size, okay, and same number of binary the bin. Okay, so that we can see, then only we can compare, right? We can only compare the distribution example like this one. Okay, you see everyone has the same upper limit 0 to 10, 10 to 20, 20 to 30. So everyone has the same. Okay, and same number of bin or class. Okay, so if you imagine I only have 0 to 20, so it might be only one line like this. So rather than have a very nice curve, it may be just dash or something else. Okay, or it become like squarey thing. I don't know. Okay, it become very ugly. So make sure they have a same number of class size, same number of classes. Okay, then you plot your histogram and you do the comparison. So you just describe what you see. So maybe for El Nino year, yeah, it has more higher rainfall. For non-El Nino year, it has higher count of high rainfall, but lower count of dry rainfall compared to El Nino years. Yeah, so something like that. Okay, just write something like that, but write in a proper word. Okay. All right. So I think that's all for the task. Let me stop recording.